Imagine you already have a detector that draws a tight box around every object and names it. Useful, but a box is blocky, and the real world is not made of rectangles. What if, for each object, you also wanted its exact shape, outlined pixel by pixel? In 2017, a paper by he and colleagues extended faster Rcnn to do exactly that, and the result became the go-to model for instance segmentation. What's beautiful is how little they had to add to get there. Today, we're breaking down what it is, how it fits together, and the one clever fix that made the masks accurate. The simplest way to see the design is to follow one object through the pipeline, because most of it is inherited straight from faster Rcnn, and only one small piece is genuinely new. This starts exactly like faster Rcnn. A region proposal network scans the shared features and suggests candidate regions that probably contain objects. Nothing new here yet, and that reuse is a big part of the elegance, since the whole detection stack already works and only needs one addition to gain masks. Then comes the key upgrade. RoIAlign crops each region's features using bilinear interpolation at exact, non-rounded locations, instead of snapping coordinates to the nearest grid cell. That precise alignment is exactly what a fine, pixel-level mask depends on. Now the network splits into 3 parallel jobs for every region. One classifies the object, another refines its box, and a third, a small, fully convolutional branch, predicts a binary mask of object versus background, all running side by side rather than one after another. And each detection comes out complete. Every object carries a class label, a refined bounding box, and its own pixel-accurate mask, all produced together in a single forward pass. That combination, delivered per object, is precisely what instance segmentation means, and it comes almost for free once the branch is in place. Now, to see precisely what changed, put this model right next to the detector it extends. The original detector gives you boxes and classes only. For each object, you learn what it is and roughly where it sits, but the outline stays a plain rectangle. You never find out the object's true shape, and overlapping objects can be hard to tell apart when their boxes cover the same patch of the image. This model adds one parallel branch that predicts a per-object pixel mask on top of the box and class. So alongside detection, you get the exact silhouette of every instance, separated cleanly from its neighbors, each one masked individually rather than lumped together, which is exactly the leap from drawing boxes to outlining true shapes. So let's pull out the 3 ideas that carry this method. A parallel mask branch. On top of the existing classify and refine head, a small fully convolutional network predicts a mask for each detected object, running alongside the other outputs rather than replacing anything that already worked. Because it is parallel, adding masks barely slows the detector down. RoIAlign preserves alignment. The old ROI pooling rounded coordinates to the feature grid, which quietly blurs the fine detail a mask needs. Sampling at exact locations with interpolation instead keeps everything pixel accurate, and that single change is what made the mask sharp. A new standard, accurate, flexible, and easy to train. This design won benchmarks, extended even to pose estimation by predicting key points instead of masks, and defined instance segmentation as a task for years afterward. Its real charm is how simple the recipe is for how much it delivers. All right, let's lock into 4 things worth keeping. This model, from he and colleagues in 2017, extended faster Rcnn to do instance segmentation directly. It keeps the 2 stages and simply adds a parallel branch that predicts a pixel mask for each detected object. RoIAlign replaced ROI pooling, sampling features at exact locations, so the masks stay pixel accurate rather than blurry. Accurate and easy to train, it became the standard for instance segmentation and even does pose estimation. If you like seeing these ideas unpacked simply, Standarity.com has a growing shelf of plain language AI explainers for you.